Alright, in the previous lecture we learned about the various types of request commands that could be sent from a Modbus master to Modbus slave. In this lecture we're going to dig a little deeper down into the read commands. There are the write commands, but they essentially set one register or one Modbus memory area block at a time. So we're going to look at the read commands. Again, let's use an example to illustrate the point. So we're seeing this from a previous example, master 3 slaves, and they have been assigned Modbus unit IDs. So let's say that we have the Modbus master in this case, and let's say it needs to read 2 memory blocks from the inputs memory area of the slave 1. Right? So the master needs to read 2 memory blocks from slave 1. Great. As you can see, the address of Modbus slave is 21. That's slave 1. The memory addresses of the memory blocks that are to be read are 10,050 and 10,057. So immediately, what the master needs to use is a read input status command, because 10,050 and 10,057 are within the inputs area, memory area of the particular slave, in this case slave 1. So in order to achieve its purpose, the Modbus master has to send a read input status command with the Modbus unit ID of 21 because it's going after slave 1, and ask for the data in memory blocks 10,050 and 10,057. But wait, unfortunately we have a little problem there. We can't specify the memory blocks to be read this way. The read input status command is great, the Modbus unit ID 21 is great, but there's a problem with the block addresses. Now here's where Modbus is a little different from many other protocols. Let's take a closer look. Remember, however, that we're concentrating on these memory block addresses 10,050 and 10,057. And what we try to do here is just specify those 2 addresses, send the message to the slave, and the slave would respond back with the data at those 2 memory blocks. So this diagram shows our example without the other 2 slaves, just for issues of space. So let's take a closer look. This is the master and slave from our example, as I said, and the diagram shows the master and slave and gives a representation of some of the memory blocks of the slave in the inputs area. You can see those memory blocks there. 10,050 to 10,057. These are 1-bit memory blocks in the inputs memory area of the slave. It's not all the memory blocks, it's some of them. Now the master is only interested in these 2 here, 10,050 and 10,057, is only interested in the data at these 2 memory address locations, but none in between. But with the read Modbus command, you can't indicate that you only want to read individual memory blocks 10,050 and 10,057, because the read input status command, like all the other read commands, only allows reading of consecutive blocks of memory. That means I can read 10,050, 51, 52, 53, but not 10,050 and then skip to 10,057. So the read input status command only allows you to specify a start block address and then the number of memory blocks to read from the start point. So in this case, in the case of this example, you would have to configure the Modbus master to send, as before, the read input status command, that's correct, together with the Modbus unit ID of 21, that's correct, but it would then specify, instead of 10,050 and 10,057, it would specify a start memory address of 10,050 and a memory block length of 8. Remember this, extremely important. So when this request is sent to the slave would return data for memory addresses 1050, 1051, 10,052, 10,053, 54, 55, 56, and 57. It would actually send back 8 memory blocks worth of data. The master would simply extract data from 10,050 and 10,057 and ignore the remaining data that it gets from 51 to 56. Now you would be able to tell that this method of data transfer is very wasteful because the master gets data that it really is not interested in. But you have to remember that the Modbus protocol is an old protocol, and at the time this method of reading data in consecutive blocks was just fine. But what I want you to remember is the overall point here. All of the read commands, read coil status, input registers, and holding registers, work in the same way. The master always requests data in memory blocks, in consecutive memory blocks, not by specifying the memory address of each block, but by specifying a start memory address and the number of blocks from the start. Okay.